Good afternoon to all of you. Myself, Dr. Sanjib Pattnaik. I welcome all of you to our particular session today, which is based on the course that is called as Operations Management. Now, this course has been coded as MMPO 003. Now, in the previous blocks, we had seen the basics and how operation management is carried out, etc. Now, in this last block, that is block 4, we are looking at the various issues in operations management. Under that, today we shall try to focus on something called as Six Sigma quality control. Many of us might be hearing about the quality control. Now, what is this Six Sigma? What it indicates us, how it operates, how quality control is done in an organization for its output. These things we shall see in discussion manner, as well as we'll try to focus on some practical problems. So, if I'm going to introduce this particular Six Sigma cost control to all of you, uh, we can say at this present era or the present times, organizations do not believe that in order to increase the profit, we have many ways by the way in which we can increase the profit. The two most widely used are either you increase the price or you reduce the cost. So, in this present area, times, price increase or cost cutting are not the primary ways of increasing profit. So, how do we increase the profit? That is our focus. This requires generation of outputs through continuous improvement in the company's operation. The products or services that our organization is going to create should be always up to the mark or ahead of the times, so that whoever are our customers will say that we are having the most recent items in our hands. That means we are talking of the quality. So the production of quality outputs, it cannot be by saying only it can be done. We have to go through the process. So quality outputs, they have to be monitored, checked that whether they are adhering to the set standards or the qualities. Now, what are the techniques used for this quality control? The techniques that are used for accomplishment of this requirement, that is quality outputs, include acceptance sampling, statistical process control, and statistical quality control. So when we are talking of acceptance sampling, the name itself will be telling us that we are adopting a particular method of sampling. Sampling is nothing but taking or getting a small portion out of the whole bunch of items that has been produced of similar kind or nature. So, when we take the sample, by looking at it, we say that whether the sample is good or not. Thereby, we try to infer that whether the whole lot is also of good quality or not. Then we go to statistical process control or statistical quality control, whereby we try to see the use of statistical techniques in our quality control. Now, in that, the sigma, those who have gone through in the statistics, sigma is all right. But simply speaking, sigma is the representation of the deviation associated with a series, a number series, or maybe a number of occurrences. Now, this sigma will say us that whether we are adhering to the average value or we are differing far off from the average value. It can be so happening that two things can have, or two items, it, items produced by two organizations may be having the same kind of length, suppose. That means the average length of the item produced by the two corporations are same. However, company A, the sigma is very low or less. Thereby, we can say most of the products produced by company A are adhering to the central value or the average value. However, company B, even though it has the same average as it is the case in company A, the length of the items produced may be far different from the average value, either too high or too low. Thereby, it will be averaging out to the average value. So, here we can say the deviations in the product quality is very high, which is not required by customers or not the objective of quality control. So, Six Sigma philosophy works towards this purpose, as we shall see as we move on. SQC, or the statistical quality control. Uh, it is a graphical representation of variation. Whenever I am talking of variation, we are talking of the sigma or the deviation from the average value. Graphical representation of variation of a process through charts and graphs. This has been developed by Walter Seward in 1924. Now here we take two kind of techniques. Techniques applied are in two directions. Either we take the help of the statistics, that means statistical process control, or we go for acceptance sampling. That means if the sample is acceptable quality, then the whole lot is also accepted. Now, what is the benefit of this statistical quality control? It helps to monitor and control the process. Now, the process is a constant lookout. If any deviations are occurring in the quality, then we try to minimize or make the deviations rectified. That means we are controlling the process. So here we can identify all kind of variations, trends, shifts, and other patterns in the process. Variation, as we said, is the hovering of the values of the items produced around the central value or the average value. When we are talking of trends, whether it is going upwards on a constant basis or downwards on a constant basis, or shifts, that means earlier suppose it was going upwards, now it is going downwards. So all these patterns will come out. What is our task here? Now we shall be taking appropriate steps to reduce the variations. Now statistical quality control charts, uh, we can show that in this format. The control charts can be drawn for both attributes and variables. Now, first of all, what is an attribute? Uh, Let me ask a question to all of you. How do you feel if you go outside now today? It is hot summer days in India. Most of the parts are suffering or passing through uh, very high temperature or humid and high temperature. In this case, if I pick up five of you and ask the question, how are you feeling today outside right now? Some may say that it is hot, some may say that it is unbearable, some may say that it is very bad, some may also answer like it is disgusting. That means the answer will be differing from one person to another because we are asking a question which is of qualitative nature. Similarly, when we are talking of outputs, we are talking of products as well as services. Products, you may find little attributes. However, we can say that suppose any product, what is the surface texture? How do you feel the surface texture of a product? The answers will vary. So, any type of qualitative aspect are called as attributes. It cannot be easily measured or quantified. Now, what are variables? Suppose I ask you, look at the device that you are holding in your hand. What is the length of that or the breadth of that? You measure it, I measure it, your friends measure it, anybody else passing out on the road will measure it. They will give the same answer. Suppose 10 centimeter length and 5 centimeter width, and the answer will remain constant. It is measurable. So anything that can be measurable is called as variables. So first we have to look at what kind of thing we are dealing with in quality control, whether those are attributes or variables. And accordingly we go for charts. Uh, Under attributes, we can have charts like charts for unlimited defects or charts for limited defects. Now, what is a limited defect? For example, we can say, suppose 10 items are taken as a sample and tested for acceptance by a qualitative characteristics. Now, uh, here the number of defects will be limited. Up to what number? 10 numbers, because we have 10 items. Similarly, we have other examples where the number of defects will be unlimited. Suppose instead of taking samples, we go for what? Verifying all the items. So there you will be finding unlimited defects. For variables, we also have certain kind of charts. As we move on, now we shall be looking at. But before going to that, let us look at statistical process control, SPC. What is statistical process control? We try to look at the process. That means the middle part of the conversion system, which is converting the inputs into outputs. So this statistical process control ensures the quality of outputs during the manufacturing process itself. So processing is the manufacturing part. So there we try to ascertain the quality. Whether the conversion system or the process or the manufacturing process is consistent. That means it is producing items which are as near as possible to the average requirement. This can be achieved through use of control charts. So process, we can say the control can be in two ways. Process under control, that means the process is working perfectly and producing the items according to our requirements or quality requirements. Similarly, we can also have process out of control. That means it is deviating far off from the average or the required values. So this can occur due to the out of process control. This can occur due to common causes. What are the common causes? Now we can say wear and tear of the machines. So it will be producing items, but certain deviations will be occurring, but which are within our acceptable limits. And if you look at special causes and need to be focused upon, then change in labor or shift change, the process may go out of control. A chart is there on the view of yours. You can look at the dots surrounded by green lines, our samples. All of you see, we have three lines. The central line is the process average. The upper acceptable limited, a limit is called as upper control level. This is the average line, and how much it can go downwards, it will represent as lower control limit. All of us see the line is moving around the central line as time is passing by. We have plotted it. However, at this time value of number 3, what has happened? This is the lower control level. This has reached lower control level and gone downwards. That means the process has gone out of control. So when it is out of control, we call it as those are due to the special causes. Now here you see, suppose this particular point, all the things are hovering near to the central value. So those are called as the normal variations or common causes. So you can have normal causes or common causes and special causes. Common causes will always occur due to the machine factor, human factor, environmental factor, etc. Normally they will occur. But uh, if you look at the out of control point, special cases, they do not occur on a regular basis. They occur due to some special cause. So whenever that happens, what we shall be doing? We shall try to negate the impact of that and try to focus how in future we can do away with that special cause problem. Now the 7 tools of statistical quality control. First is flowcharts. Now it is in the form of a flowchart. Second is check sheets. Now it is very difficult to remember all the problems occurring in a large organization. So what we do? We try to maintain a check sheet. All of you see we have an example of computer related problem where the problem is network. Why computer is malfunctioning? Whether it is due to network, is it due to server, is it due to email, or is it due to server access? And the weekly status also we try to see by using the tally marks. So we say computer faces problems maximum due to emails followed by server access, then network problem, then finally server problem. So here we can say yes, if we check the email first, then most of the problems will go away. Uh, if you look at the check sheet, another important thing coming out in a month, week 2 and 4 are showing maximum problems. So here we can analyze why this particular even weeks are giving us more problems. Histograms. So here we try to see what is the frequency of occurrence of problems in any given uh, time period. So when we look at the histogram, you will find around the central value, that is of 52 or 51 odd, Most of the high towers are there. See, high towers are there near to the average. Similarly, another tool is Pareto analysis. Now, what is this Pareto analysis? Now, here we can say it has been developed by an economist called as Alfred Pareto. He was of the view that if we take the whole world and the wealth present in the world, then three things are very clear. First, 10% of the people out of the total will be having or owning 70% of the total wealth available. That means the super rich. Further, he added 70% of the people in the world will be owning only 10% of the wealth of the world. That means the lowest uh, segment of the society. Then we have a middle group where we can say 20% of the total people having 20% of the total wealth. So the bottom line of this Pareto analysis is uh, most of the problem that is occurring in a process may be due to a few things. If we can take out those few things, most of the problem will go away, or maximum problem will be done away with. See here, we have five different kind of problems, and maximum is this followed by this. So if we try to rectify these two problems, then at most out of 100% problems, this will reduce to around 15 to 20%. That means 80% of the problem of ours has gone out. Another one is the scattered diagram. Now in this scattered diagram, we take two things, suppose age of the machinery and the length or average length of the items produced. So different things will come out which we can plot it as these points in a 2D graph. Suppose in the x-axis we can take average age. Now when we have the scatter diagram, we can know by drawing a straight line which best fits or which will be nearer to all the points, then we say that yes, this is what is our average production. The problems will automatically die down. Then we look at control charts. Just now we had seen within the control limits, upper as well as lower, our items should be there so that the process is called as in control. And if it is breaching beyond them, then we call it as the process is out of control. Another important tool of statistical quality control is cause and effect diagram. Now, here you see we have materials, here we have environment, process, people. Uh, we are looking at why shipment is getting delayed. That means the item being sent to the customer are getting delayed to get delivered. So we take what are the probable causes, whether it is availability of material to produce, whether process is suffering from certain kind of problems, is there any kind of environmental disturbances, whether there is worker problem, etc. And for each of the cause, we try to look at what are the effect or impact on the shipment delays. Thereby, we can know what exact factor is causing the delay. And if you look at carefully this one, it looks like a fishbone. This is also called as fishbone diagram. Another important tool of statistical quality control is runs or run chart. Now, we take a continuous measurement of the items that are being produced and plot it or plot the measurement on a graph on a continuous basis. Here it has been marked as red. What is the general trend here? Now it is moving upwards. Here we cannot get any trends because only one or 2 points are there. Then the trend is shifting and moving upwards, then coming down but not continuing, then going upwards, then it starts to come down for a fair length of time. So here we are having a second type of run, that is decreasing. So runs chart will help us to identify the patterns in the measurements of the items produced. Now, as we have said, we shall do some practical problems based on control charts. So we shall look at one of the most important one, that is mean range charts, or we can call it as X bar R chart. X bar is the mathematical representation of mean, R is the mathematical representation of range. Now, construct the mean range chart and comment. Certain values are given, I will tell you how to get those values. All of you see, I have taken how many samples? Now, 5 samples. So, we say 5 samples. K is equal to how many samples? 5. Each sample how many items are tested in each sample? 3 items. So n represents number of items picked up in a sample. Now we have to find out sample mean. That means the sample average. Suppose the first sample. How do I get it? Now what I will do, I will add all the items 10.5 plus 10.46 plus 10.62. That means addition of all the items divided by number of items. So that I get suppose as 10.5. What it means? The first sample average is 10.53. Now sample range. What is this range? The range is the difference between the highest and the lowest value in the sample. Now in this particular first sample, highest value is 10.62 minus lowest value is 10.46. So I get a value of 0.16. Now we'll start calculating all the sample means as well as the sample range. All of you can calculate this now. So the second one is 10.43. These are the sample averages. Similarly, I find out all the range of all the samples. What I will do now, I will try to find out x double bar, that is called as grand mean or mean of the mean values. We have 5 mean values. So what we can do? This is symbol of summation of all x bars. That means all the sample averages I will add up. Whole divided by k, number of samples. So it gives me a figure of 10.49. Now I also find out the R bar. that is equal to addition of all R values divided by K. So that gives me a figure of 1. Now I shall proceed to prepare the X bar chart. So what I will do, you can use your scale for better pictures. So this is my central line. I am representing a central line that is equal to X double bar, that is equal to 10.49. Now for the UCL upper control level, we try to find it out as X double bar plus A2 R bar. Now the question is, what is this A2? Now A2 is a constant which is based on number of items contained in each sample. Our each sample here contains 3 items, so n is equal to 3. So based on n is equal to 3 from statistical tables, we get A2 as 1.02. So if I put all the things in the formula now, X double bar I know, A2 I am getting as 1.02, R bar also I have calculated, then the value comes out as 10.61. Similarly, lower control level is equal to X double bar minus A2 R bar, and that gives me a figure of 10.37. So I have got all the line values. Upper control is 10.61 and lower control is 10.37. Once I get all the line values, I will proceed to prepare the chart. Look at the first sample. What is the X bar value? We got 10.53. I presume for the first sample, 10.53 will fall somewhere here. Now let us go to the second value, 10.43. It will come downwards. Then 10.47. Then 10.55 goes upwards. Then 10.48 is somewhere suppose here. I have got all the 5 points for individual samples. Now I join them either using freehand or using a scale. What I find here is, if you look carefully, the line is within both the control labels. That means we can say yes, the process is under control. Similarly, in order to justify our results, we go for R chart. Now, in this R chart, again we have three different lines. As from our discussion, we know the central level, the central limit, the upper control limit, and the lower control limit. Now, central limit is our R bar. So I can put here as 0.12. The upper control level is calculated as another constant from the statistic table, D4 into R bar. D4 is given as 2.57. So when I calculate it, we get the value as 0.31, and lower control limit is D3, still another constant based on number of items in the sample, into R bar. So D3 here is 0, so this is 0.00. What I will do now, same way as we did for X bar chart, we'll plot all the points of R. For the first R is 0.16. Second point is again 0.16. Third point is 0.05. Fourth point is 0.11. And fifth one is 0.12. And I join up the values using a scale. Again, I find they are falling within the control limits. So we can comment that yes, the process is under control. Now, let us look at P chart, proportion defective, or percentage defective. So here construct P chart and comment. It is given as 5 samples of size 10 are inspected. That means in each sample, how many items were picked up? 10 items. Out of the 10 items, nothing can be bad. One can be bad, two can be bad, or at most 10 can also be bad. So first we try to find out what is the percentage of defective. So the first one or the first sample, one one item is defective out of 10. So 1 divided by 10 into 100, that is equal to 10% or 0.1. Second one is also 0.10. Third one is 0.20. Fourth one again is 0.30. And last one is 0.10. Now, once we get it, what is the total amount of defective? Now we add all the percentage defective. So that gives me a figure of 0.80. Now, these are the p values. Now, I can find out percentage defective or proportion of defective average p bar is equal to total of p values divided by number of samples, that means k, that is equal to 0.80 divided by 5, that gives me a figure of 0.16. Now, as we know, for any control chart, basically we require 3 lines. The central line or central limit, this is upper control limit, this is lower control limit. Now this central line is P bar, or we can say it is 0.16. Now upper control limit is equal to P bar plus 3 into root over of n is the number of items in the sample. P bar already we have calculated as 0.16. So when I put all the things, I get a value of is equal to and lower control level or limit is P bar minus 3 root over of P bar into 1 minus P bar by n. That gives me a negative value. Whenever it is negative, we have to take it as 0. So now we go on to plot the values. the first value, second is also the same, third is fourth, and fifth again, and is joined by a straight line. So we can say the process is under control. So this is the way we go for control charts. Now we go to the Six Sigma. As we said, sigma is a Greek symbol which says about how much is the deviation or variation in a process. It measures the capability of the process to perform defect-free work. So higher the sigma level we are using, the less is the defect that is likely to occur. So we say as sigma increases, defects decrease. The objectives of this philosophy Six Sigma is how to reduce the defects, the cycle time reduction, and ultimately how to enhance or magnify the customer satisfaction. Now, this Six Sigma is based on the normal distribution curve. Uh, this curve is used in statistics, research work, etc. And it has been seen this happens in all the phenomena of real life as we go on increasing the information. We see, suppose one standard deviation below the average value that is written as mu, the central line mu, or one standard deviation above the central line that is mu, 68.2% of the items that are happening will definitely fall. Similarly, 4 sigma, that means below 2 and above 2, 2 sigma we can take on both the side. We can say 95.4% of the items will be falling under these two boundaries. Similarly, 3 sigma level, which most of the organizations are operating, they say 99.7% of the items definitely will be error free. To predict defect cases, Six Sigma uses the theory of normal distribution curve. So, the process capability is the measure of statistical control. So, process capability index is upper control level minus lower control level by 6 sigma. So when we are having sigma levels, percentage of defectives that are likely to occur in a process is for 1 sigma, 70% defectives may occur. For 2 sigma, 31. For 3 sigma, 6.7% of the items will be or may be defective. If we go to 6 sigma, then it is only 0.00034% will be only defective. That means such is the high quality that we are producing. The defects per million opportunity, if we look at the DPMO, that means defects per million parts that are produced. If we go by 1 sigma, Then the defects produced per million, that means 10 lakhs, is 6,91,500. It is not at all acceptable. As we move on to higher level of sigmas, and at 6 sigma level, we produce world class items. That means for 10 lakh items, only 3 items will be defective. The Six Sigma methodology is based on DAMIAC, define the item, measure it, analyze, innovate new methods, improve it, and have a control process to check it. When you are applying Six Sigma philosophy to an organization, the participants are usually categorized into 5 categories in the hierarchy level. You start with the lowest hierarchy, yellow belt, that means the general workers. Then the green belt were the supervisors. Then black belt, divisional managers. And master black belt, functional managers. And champions, the management, will back the Six Sigma. With this, we try to complete our session here, which is based on Six Sigma philosophy. We'll meet again. Thank you.